So we'll see software maintenance, which is a very important part of your SDLC or software development life cycle. So let us start with this software evolution. Now, it is impossible to produce system of any size which do not need to be changed. There has to be a change, and once software is put into use, new requirements emerge and existing requirement changes because the business running that software changes, and change is the only thing which never changes, right? So even infinitesimal small changes will be there. So part of the software may have to be modified to correct errors that are found in the operation, to improve its performance or other non-functional characteristics. Means we are not only talking about the functional characteristics. There may be non-functional characteristics as well. So all of this means that after delivery, once you have delivered, software system always evolve in response to demand for change. Then program evolution dynamic is the study of system change, which we are talking about, program evolution dynamic. So the majority of work in this area has been carried out by Lehman and Bilady. So from these studies, they propose set of law which concerns to this system change. What are these laws? Continuing change and increasing complexity. What is this continuing change? A program that is used in real world environment, which is necessarily must change or become progressively less useful in the environment. So there has to be a change, otherwise it will be useless to the environment. And increasing complexity, that means as an evolving program changes, its structure tends to become more complex. So extra resources must be devoted to preserve and simplify the structure. There has to be, and there is always a push to decrease the complexity. And then large program evolution. Program evolution is a self-regulation process. System attributes such as size, time between release, and the number of reports of errors are approximately invariant for each system release. And what does this organizational stability stands for? Because over a long period, or this that is a program lifetime, its rate of development is approximately constant, and this is independent of the resources which has been devoted to the system development. So the organizational stability is this, and conservation of familiarity. Again, over the lifetime, the incremental change in each release is again approximately constant. There are various approaches to software evolution. There are a number of different strategies of this software change. First of all, we have software maintenance, architectural transformation, and software reengineering. What is software maintenance? Changes to the software are made in response to change requirement, but the fundamental structure of the software remains stable. Means the architecture, architecture I should not say, because there is other strategy which is named as architectural. So we say that the structure of the software which will remain stable, will remain almost similar, and there are certain change which is to be done on these. So this is the most common approach used in the software system change. Then comes the architectural change. Now there is more. This is actually a more radical approach to software change than maintenance, as what it involves is making significant change to the architecture of the system itself. Then comes the software reengineering. This is now different from these strategies in that no new functionality is added to the system, right? In this and the previous one, new functionalities are added or may be added, but here it is not. So system reengineering may involve some structural modification, but does not usually involve major architectural changes. System engineering, some structural modification, no architectural change. So what are the different types of software maintenance? Software maintenance is actually a general process of changing a system after it has been diverted or delivered. Now the change may be simple changes to correcting coding errors, more extensive changes correcting design errors, or significant enhancement to correct specification error, or right, or also to accommodate new requirements. There are various maintenance characteristics. We need to look at maintenance from three viewpoints. First is the activities required to accomplish the maintenance phase and the impact of software engineering approach on the usefulness of these activities. Then comes the cost, which is associated with the maintenance phase, and then the problem that are frequently encountered when software maintenance is actually undertaken. We are continuing our maintenance talk, and this is type of maintenance. Maintenance is to repair software faults, so say changing a system to correct deficiency in the way meets its requirement, and maintenance to adapt this software to different operating system, like so changing a system so that it operates on different and various types of environment for its initial implementation, right? And maintenance to add to or modify the system functionality, means modifying the system to satisfy new requirement as well. So this is the maintenance effort distribution. This is this part 17% is around fault repair. This is software adaptation, and this is functionality addition or modification. So 65% of the part is functionality addition or modification, while software adaptation is 18%, while fault repair is 17%. So what is the difference between a development and maintenance? People will ask. Development not directly linked to the real world, directly real to the real world maintenance. And development you have freedom, while maintenance the system is already existing, so you are constrained by it. In development, defects have no immediate effect, but at maintenance, when production is going on, it defects disrupt production. In development, methods are available, but in maintenance system not using current methods. While in development, standard may be enforced, but now standards has to be shifted, if any. For example, maintenance example will take Y2K. Many systems have to be updated. See, in the year 2000 it happened, and language analyzers, for example, find where changes need to be made. This were Y2K problem. And antivirus software, they don't usually have to update software, but must send virus definitions. This is on ongoing activities always. Operating system patching, like there are various OS which are released and then patches are coming, and OS is core to use of computer, so it must be constantly maintained. Then commercial software in general, customers need to be informed of the updates, and updates have to be easily available. Web is a good tool now. Then the maintenance process. The maintenance process actually they vary considerably depending on the types of software being maintained. The development process used in an organization and people involved in the process. Let us see them. This is the overview of the maintenance process. We receive a change request, then we see the impact analysis, then release planning, then change implementation is done, system release, and then again any change requirement is there. So here we do the fault repair, here flat for form adaptation, system enhancement. So what are the change requests? Change requests are requests from system changes from users, customers, or management. So what exactly is all change requests should be carefully analyzed as part of this maintenance process, and then they have to be implemented. But in practice, some change requests must be implemented urgently, like fault repair, changes to the system environment, or urgently required business changes. This is the part of change implementation. These are the proposed changes, requirement analysis of requirement updating, and the software development. These are the change implementation processes. And as I earlier indicated, emergency repair, change requests come, we just analyze the source code, modify the source code, and just deliver the system. This is emergency repair. And why is maintenance inefficient? Because factors adversely affect maintenance are lack of models or ignorance of available model, lack of documentation. See, this is around 67.6%, and this is 73%, and lack of time to update existing documentation is 54.1%. There are other factors also. Quality of original application is not good, document quality is not up to the mark, the rotation of the maintenance people is not planned properly. Then there are more factors for by YIP 95 study. There are, or they may be, lack of human resources, different programming style conflict, lack of documentation and tools, bad maintenance management, documentation policy, and of course turnout. This turnover may affect. There are various maintenance techniques. First is architecture evolution. So there is, we have seen software maintenance. Now we are coming to architectural evolution. So there is a need to convert many legacy systems from a centralized architecture to client server architecture. What are the chain drivers? Hardware costs and servers are cheaper than mainframes. That is why. User interface expectation, that is user expect graphical user interfaces now, and distributed access to system, that is user wish to access the system from different geographically separated computers, right? So the factors, these are the distribution factors. Business important, system age, system structure, and hardware procurement policies. I hope you get the idea of what I wanted to highlight here. Business importance, we return the returns on the investment of distributing a legacy system depends on the importance to the business and how long it will be important. So if distribution provides more efficient support for stable business process, then it is more likely to be cost effective evolution strategy. In the similar way, system age, if it is older, you have to change it to the newer version. System structure, if it is the more efficient architecture are available, you have to change it to the new architecture, and also to migration to different hardware. Then hardware procurement policies. Previously, it was made for some hardware. Now you have cheaper servers. You can go with cheaper servers. So legacy system structure, ideally for distribution, there should be a clear separation between the user interface, the system and services, and the system data management. But in practice, they are so intermingled in our legacy system. So in legacy system, the ideal model for distribution should be user interface, services, and database should be, they should maintain different tiers. While in legacy system, you have this jumbled up situation. And there has to be a layered distribution model like presentation, data validation, interaction control, application services, and database, right? And in legacy system distribution, you see the application, these are character terminals, their database, user interface, application services. So we have this desktop PC client running on program. This is how legacy system work. Just have a medieval where layer, a wrapper, and it provides the services to the clients. There are distribution options also. The more that is distributed from the server to the client, the higher the cost of architecture evolution. The simplest distribution model is user interface distribution, where only the user interface is implemented on the server. So the most complex option is where the server simply provides data management and application services are implemented on the client. This is distribution options spectrum. These are the server, these are the clients, these are the client part. So this arrow shows the increasing cost and effort. So if the server is database and the client needs to be presentation, interaction control, data validation and services has to be there, then the cost is very high. While if the client only have presentation and all the other work like interaction control, data validation, services and databases are performed on the server, the cost is somewhat less. So user interface distribution, this takes advantage of the local processing power on the PCs to implement a graphical user interface. So where there is a clear separation between the user interface and the application. Then the legacy system can be modified to distribute this user interface. Otherwise, what happens is screen management behavior can translate these text interfaces to your graphical interfaces. This is how I was speaking about. That user interface distribution, these are the legacy system. Your application, services, database, and user interfaces. These are the screen description. And we have a middleware, screen management. The desktop PC clients with GUI interfaces will work upon that. Now, user interface migration strategies, you have implementation using the window management system or implementation using web browser. You use simple user interface or you go to the web. But there are various advantages and disadvantages as mentioned here. So this was the first part. We'll be discussing about this more. Thank you so much.